Hello and welcome to Arithmetica. This video is the second episode of our introduction to propositional logic. In the first video in this series, we provided some understanding of the formal language that is used in both mathematics and propositional logic. In this video, we shall begin with our formal introduction to propositional logic before detailing how such statements in logic can be combined. To understand proof, it is prudent to appreciate aspects of the philosophy of logic and language, in particular the ability to recognize how complex structured propositions have been composed from simpler elements. Propositional logic, or otherwise known as the logic of statements, is the branch of logic concerned with form rather than content. That is, what can be derived from its fundamental structure rather than from the meaning of the propositions themselves. Propositions can be constructed from others in a variety of different ways. It is important to understand that the propositions so used in the construction of others need not be true statements, and as such the resulting combined statement can be either true or false, as one might well expect. Remember, conclusions in deductive logic and that of propositional logic follows from form, not content. This is emphasized from the philosophy that statements can be true or false, but not valid and or sound, while a logical argument in deduction is valid and or sound, but not true or false. We refer to any proposition which is the formulation of the combining of others as a compound proposition or compound statement, and those that cannot be broken down into simpler components as simple statements. So let us take a look at some basic ways of combining propositions. We shall start by considering non-mathematical objects. Consider the two sentences. The first one, Nelly is an elephant, and the second, Nelly has a long trunk. We identify both of these sentences as propositional statements, since it is meaningful to speak of their truth or falsity. That is, Nelly is either an elephant or she is not, the truth determinable via taxonomic classification. Moreover, regardless of how debatable it may be as to how long her trunk is, say by arguing by comparison of average trunk length of the same species, it is either long or it is not long, i.e. of typical length or shorter. Despite any subjectivity as to how we assess the meaning of these sentences, the fact remains they are either true or they are false, and as such are statements. Remember, formal logic cares nothing of the meaning in content, only that they can be recognized as being true or false, and how such statements are structured. We begin by considering a compound proposition called a conjunction. These are propositions that are formed by combining two other propositions via the connecting word and. For example, the conjunction of these two statements can be written: Nelly is an elephant and Nelly has a long trunk. Once we have such a conjunction, the two component propositions are then referred to as conjuncts. Thus, in this example, the conjuncts are statements 1 and 2, i.e. Nelly is an elephant and Nelly has a long trunk respectively. A reasonable question might be with regards to the truth of such a compound proposition. Generally, the truth or falsity of a compound proposition is often defined in a truth table, determinable via the possible truth values of its component propositions. Let us denote the letter A for proposition 1 and the letter B for proposition 2 for this particular example. We also use this symbol shown here to denote the act of applying a conjunction. This symbol is an example of a logical operator, or otherwise called a connective. Thus symbolically, we can write our example conjunction as. It is also worth noting that some authors favour the use of the ampersand symbol as the logical operator in the construction of a conjunction. Let us now consider the truth or falsity of propositions A and B and how that might impact on the truth value of this conjunction. Consider the following truth table of our two propositions, 1 and 2, and their conjunction. The letters T and F denote the truth or falsity of the proposition respectively. They are called truth values, which we touched on earlier in this series. As you might well expect, there is nothing special about the symbols being used for the truth values. Many authors use the number 1 for a truth and 0 for when a proposition is false in their truth tables. Moreover, the truth table has used nothing from the meaning of propositions A and B. It is true in general that a conjunction is true if and only if its component propositions are both true. That is, for any two arbitrary propositions P and Q, their conjunction is true if and only if P is true and Q is true. And so our example conjunction, Nelly is an elephant and Nelly has a long trunk, is true only if Nelly is indeed an elephant and that Nelly really does have a long trunk, which of course is what one might well expect given one's understanding in language and of the form of a conjunction. When writing compound statements, there are a number of equivalent ways of phrasing them. Here are just a few ways of expressing the same conjunction. Lucky is a cat and Lucky has 3 legs. Lucky is a cat. Moreover, Lucky has 3 legs. Lucky is a cat. Furthermore, Lucky has 3 legs. Lucky is a cat, yet Lucky has 3 legs. Lucky is a cat, although Lucky has 3 legs. Lucky is a cat, even though Lucky has 3 legs. Thus, what serves as the logical operator of a conjunction is obviously not always going to be the word and, but rather, as one might well expect, be a word or phrase that has equivalent meaning in the written form that induces the equivalent corresponding conjunction. It is also worth clarifying that the conjuncts need not necessarily share the same subject, as in the case of the previous 2 examples of Nelly is an elephant and Nelly has a long trunk, and Lucky is a cat and Lucky has 3 legs. Another example of a conjunction would be Tom is a cat and Jerry is a mouse, where the 2 constituent propositions, Tom is a cat and Jerry is a mouse, have no relationship other than a rather turbulent and entertaining one in children's television. But this should be expected given our explanation on how propositional logic is concerned with form and not content in meaning. To finish off our discussion on conjunctions, let's consider one with a mathematical context. Let C be the proposition the real number 5 is greater than 2, and D be the proposition the real number 5 is less than 10. Then the conjunction of C and D could be written: the real number 5 is greater than 2 but is less than 10. Mathematically, we might write this down thusly: read as 2 is less than 5, which in turn is less than 10. That is, 5 is strictly between 2 and 10. This concludes our second video in the series of our introduction to propositional logic. In the next video, I will be continuing our account on compound statements in considering the disjunction operator. You might also be interested in watching the accompanying video of exercises for this episode. Please feel free in clicking on the annotation or alternatively on the link in this video's description. And so until next time, it's goodbye from Arithmetica! And it's goodbye from Pumpkin!